Right, so last page of the exam, and this is, the previous pages are my favorite questions, but I've always been a big fan of mechanisms and, just using them to kind of see what happens here. So let's take a look at these mechanisms. So the first one here, nice and to the point, we got a pinnacle rearrangement. Useful to kind of keep this one in mind, just given the next set of reactions that we're going to go through. The most important thing I can always ask you guys to do is just, note some of the similarities or the circumstances when we're going through with our mechanisms here. So we're under acidic conditions, and that typically means we're going to use the acid in the first step and probably have a cation. And we can guess that we have a cation here because we see some kind of large structural rearrangement. So, that's always kind of a good indicator, right, that, we have some kind of cation that forms. We have alcohols, we have acids around, so, the first step is going to be protonation of the alcohol. So let's go do that. You know what, I gotta go back and change. Let's see here, what color? Let's do that. All right. Let us try this one more time. Much better. Okay. So we got this and got that. So both of these alcohols are equivalent. So we can pick either one of them in this case. So we will protonate to make a good leaving group. So let us make it leave. Not too bad. All right, we can do the ring contraction here. All right, this is the kind of the tricky part here. Just kind of paying attention to the different carbons involved in this, right? So we break the bond between the black and the purple to make a bond between the black and the green. So if we do this, let me try and draw this in a manner to maybe make the point. There's that. Do you guys catch that? Right, so we're basically just moving the bond between black and purple to black and green. It just kind of looks weird, but maybe if you're having trouble kind of visualizing this, or then hopefully this might help out there. Okay, and we forgot the most important part, which was the positive charge, the carbocation. So we will do this, and then I'm just going to make this look prettier. Well, as pretty as I can make it. You guys know how my drawings can be at sometimes. And then something's going to come along. We will just call it generic base. Probably the water, maybe more the alcohol from a different group. And then we will get to our product. Fantastic. All right. There it is. Cool. Not too bad. Interesting way to make a carbonyl. Maybe not the best way to make a carbonyl, but whatever. Okay. Next, again, we're under acidic conditions. Looks like we're doing some kind of cyclization. You see a structural rearrangement, so probably some kind of cation happening here too. All right, so let's get to it. So here, let's see, 1, 2, 3, 4, 5, right? That looks good. I'm just going to abbreviate the sulfuric acid as H+. I'm not going to be too picky about that kind of stuff. Although technically speaking, right, we should show, exactly what's going on there. But to be honest, I'm kind of lazy this morning. There we go. We've made a good leaving group, so we make that leave again. All right, let's migrate a methyl group because we've got a carbocation next to a quaternary carbon. That's kind of a good indication of a methyl rearrangement here. So 1, 2, 3, 4. So we got this, we got that, we got that. Okay, now we got a stable carbocation. Let's cyclize this, right? So I'm going to bring this down here. So now we got this, right? Let's see, we got that carbon, 2, 3, 4, 5, 6, right? So we know we're going to make another 6-membered ring. 1, 2, 3, 4, 5, 6. Okay. So carbon 1 and 2 is where the double bond started. 3 and 4 had nothing on them. 5 had a methyl group. 6 had 2 methyl groups. And so we took the bond and made it between 1 and 6. So carbon number 2 has the positive charge on it. All right. That's one of my kind of secrets to success there. It's easy for me to like drop things and forget things. I've got tend to have a somewhat forgetful personality. So what I kind of learned to do, or what I was told to do, is that, just write out the numbers or use colors or whatever it might be to figure out which 2 carbons you're bringing together, All right, some kind of base here. And that looks like it's going to get us to where we need to go. Nice. All right. Good stuff. So it's just some kind of acid catalyzed dehydration, some ring closing here, not too bad. I like it. All right. Now we get to something a little bit newer here. All right, this was an ether. Truthfully, there's a couple different methods, I guess you could, to get to the product here. I'm going to show you which one I like the best. It's not necessarily the only answer I accepted here, right? I think there's definitely some wrong ways of doing this, right? There's definitely some wrong ways. If you're generating a dication and stuff like that, don't do that, right? You're not going to generate a dication. But anyway, we have an ether under acidic conditions. Alright, so what I'm going to do is let's go like this. So we can make our methanol. Okay. So we can probably go ahead and boot this off. We can do something like that. And let's just go ahead and bring this part in here. Oops. And we'll clean this up. Oops, I dropped the carbon. Sorry about that. There it is. Okay. Okay, that looks alright, That is one way of doing this. You could start by protonating the oxygen in the middle there, and that would be okay, right? Truthfully, I think given kind of the information that we have, there are, like I said, there are wrong ways and there are better ways, but, this one looks okay to me. I think this kind of avoids any steric, like some of the steric issues that we have with some of the other mechanisms that we could bring in this case. But certainly there's certainly other acceptable mechanisms. But this one's reasonable, and it follows the rules that we have, and it gets us to where we need to go. Okay, so there it is. There's the last page of the exam. Not too bad. Let me make a couple quick comments about the exam in general. The grades weren't, they weren't all that bad. Like I said, I think the biggest thing to take out of this is how to answer these questions here, right? Questions 2 and 3, right? So definitely go back and take a look at those videos there. I tried to keep them short, so if you're missing something or still want some answers, please just contact me and I will get back to you, okay? All right, we're done, and that should be it for this, and we will keep moving along with the lectures also. All right, see you guys.